Okay, so I'm looking at page 7 in your notes, mass to mass conversions. So mass to mass conversions are the longest problems that you'll be asked. I'm going to give you the mass in grams of one substance and ask you to find the mass in grams of another. To do these, it takes 3 steps to get to your final answer. So let's start out by identifying our given, which is 50 grams of iron 3 oxide. And I'm asking you to find the mass of carbon monoxide. So in your flip book or on my mole road, what I give you is called A, and what I'm trying to find, I like to label B. So we're going to start out by writing down our given, which was 50 grams of Fe2O3. And from here, I need to turn grams of Fe2O3 into moles of Fe2O3. I need the molar mass of iron 3 oxide, which is 159.7 grams in 1 mole. The next step on my mole road asks me to turn grams into moles. I need to use the mole ratio. There's 1 mole of Fe2O3 for every 3 moles of CO. And then the final step, now that I've turned my A into a B using the mole ratio, is to find the molar mass of CO and turn moles into grams. So carbon monoxide has a molar mass of 28 grams in 1 mole. And then to solve, I'm going to take and multiply across the top. So 50 times 1 times 3 times 28, 4,200, divided by 159.7. And I get a final answer of 26.3 grams of carbon monoxide. Let's look at number 2. Number 2 asks how many grams of potassium chloride are produced if 25 grams of potassium chlorate decomposes. So I'm asking you to find the grams of potassium chloride. And I gave you 25 grams of potassium chlorate. To start, I'll write down my given, which is 25 grams of KClO3. And I need to turn grams of KClO3 into moles of KClO3. KClO3 has a molar mass of 122.5. So now that I have moles of KClO3, I need to turn moles into grams using my mole ratio. There are 2 moles of KClO3 for every 2 moles of KCl. And then finally, I need to turn moles of KCl into grams of KCl using my molar mass, 74.6 grams of KCl in 1 mole. To solve, I'm going to multiply across my top. So 25 times 1 times 2 times 74.6, 3,730. 122.5 times 2 is 245. And then when I divide 3730 divided by 245, It's 15.2 grams of KCl for my final answer. So just to kind of go over where those numbers came from, 25 was given to me in the problem. I started out with 25 grams of potassium chlorate. 122.5 is my molar mass of KClO3. The 2 and the 2 are my mole ratio, and I got those numbers from the coefficients in the balanced equation. And then finally 74.6 is the molar mass of KCl. Question 3 asks how many grams of silver chloride are produced from 5 grams of silver nitrate. So I started out with 5 grams of silver nitrate, and I'm asking you to find grams of silver chloride. I'll start by writing down my given, which was 5 grams of silver nitrate. Then I need to find the molar mass of silver nitrate, which is 169.9 grams of silver nitrate in 1 mole of silver nitrate. From here, now that I have moles of silver nitrate, I'm going to turn moles into moles of silver chloride using my mole ratio. There's 2 moles of AgNO3, so silver nitrate, for every 2 moles of silver chloride. And then finally, I need to turn moles of silver chloride into grams of silver chloride using the molar mass, which is 143.3 grams in 1 mole. So let's multiply our top. So 5 times 1 times 2 times 143.3. That's 1,433. And then multiply the bottom, 169.9 times 2, 339.8. And I'm going to divide those two numbers, so 1,433 divided by 339.8. And I get 4.2 grams of AgCl for my final answer.